But can one of you tell me what are the brakes? कोई भी. Can you pass the mic over in the audience? Can anyone of you tell me what are brakes? What are the purpose of installing brakes in the vehicle? Anyone? Yeah, the guy over here. Can you pass the mic? Volunteers? To stop the vehicle. Okay, and how do we stop the vehicle? By applying brakes. But can you talk in the physics terms that how we stop? So by the help of friction. So due to friction, what happens exactly? Sorry. So while vehicle is in motion, so there is some energy that the vehicle is having, right? So we need to convert that energy. Okay. So brakes is all about just physics. There are some governing laws of in physics. So first we'll talk in general about brakes. So we have four types of brakes in general. So first will be the mechanical brakes. So बचपन से अपन साइकिल वाइकिल चलाते हैं तो उसमें जो रहते हैं वो ब्रेक पैड्स रहते हैं and with the help of wire we used to actuate it. Okay, so those are typical mechanical brakes which we used to see in bicycles and motorcycles. Then second type of vehicle brakes are pneumatic brakes. Okay, so our trucks, trailers में रहते हैं वो railways में रहते हैं. Then third is the hydraulic brakes, which is a major part of concern for this presentation, and which we used to see mostly in two-wheelers and passenger cars, sports cars. And the fourth one is electronic brakes. We used to see in performance high performance vehicles like F1 cars and high performance cars. Okay. So basic basic what we need to look after the basics are the laws of physics, okay, governing equations, then inertia and frictional forces, and then we need to look after how should we select the system and the system's compliance with the rule book as well as the installation functional. So the installation must be in the way that the system should be functional and robust. Okay. So the main equation around which we are going to play is the equation of kinetic energy, which is half m v square. Okay. So the next is we are going to talk about some bleeding procedure. Okay, so once you done designing the system, so what will be the first step to do in the brakes? Okay, then typically we used to like neglect this topic, but the contamination of the brake fluid, the lubrications which we are going to use, the durability of your braking system, and the servicing. Okay, so what your rule book says is your all four vehicles must be locked simultaneously. Okay, your pedals should be rigid. Then the brake circuit should be there for the front and rear. There should be two independent brake circuits. Okay, and the stop light switch must be there on every system so that the brake light will glow once you apply the brakes. Right. So the governing laws, which we are going to talk about, the first one is the Pascal's law. So can anyone of you tell me what is Pascal's law? Anyone of you knows Pascal's law? So the Pascal's law says that whenever we apply pressure on the non incompressible fluid, okay, so that pressure itself used to means travel through that incompressible fluid and transmits equally in all directions. Okay, then there will be the equations of motion which we are going to talk about, theories of friction. Okay, so as like the guy said over here that brakes is all about the friction. So theories of friction and the gravitational force. What is the value of G? 9.81, and what is the unit? Meter per second square. Okay. So these are equations of motion, and the equation which we are going to play about will be the second equation, that is v square equal to u square plus 2s, in which v will be your final velocity, u will be your initial velocity, a will be your acceleration or deceleration, whatever it may be, and the s will be your stopping distance. Okay. So now you're going to design a system. Okay, so there are two counterparts. One is the forward engineering approach, one is reverse engineering approach. Okay, so to design anything, first we should know that what will be your end product. Okay, so आपके गाड़ी को ब्रेक्स लगाना है, मतलब आपको एंड में क्या करना है कि गाड़ी को इधर स्टॉप करना है या डिसलेरेट करना है या फिर गाड़ी को एक जगह पे होल्ड रखना है। सपोज गाड़ी आपकी चढ़ान पे हो या ढलान पे हो तो ब्रेक्स दबाने के बाद वो गाड़ी वहीं पे रहनी चाहिए, राइट? आर वी गुड ऑन दिस? So these are three main functions of the brakes, right? So initial criteria is final velocity minus initial velocity, right? So now first we will see the reverse engineering approach. Okay, so किसी भी गाड़ी को स्टॉप करना है तो उसके पहले बेसिक्स क्राइटेरिया अपन जान लेते हैं। लाइक देयर विल बी द स्टैटिक वेट एंड डायनामिक वेट, डायनामिक एक्सल लोड एंड स्टैटिक एक्सल लोड। किसी को पता है ये चीज क्या है? एनीवन? सो आपके गाड़ी का एक मास होगा, राइट? एक वेट होगा आपके गाड़ी का, बराबर? सो दैट weight is distributed in on your front axle as well as rear axle. Okay, so the weight on the front axle will be known as the front axle load and the weight on the rear axle will be known as rear axle load. Okay, so आपके सस्पेंशन डिपार्टमेंट से आपको ये मिलेगा कि व्हाट विल बी योर पॉइंट ऑफ सेंटर ऑफ ग्रेविटी, राइट? सो सीजी के पॉइंट के ऊपर से यू कैन डिस्ट्रीब्यूट द लोड अकॉर्डिंगली ऑन योर फ्रंट एंड और योर रियर, सो विल गेट द वैल्यूज ऑफ front axle load and rear axle load. Then you will be having your wheelbase with you, so you will know that 56 inches, 55 inches, what will be the value of the wheelbase. You know the exact mass of the vehicle, exact weight of the vehicle in newton. Okay, and as per the rule book, the vehicle must maintain the speed of 40 kilometers per hour and then needs to decelerate. Okay, and on that deceleration, these all parameters are going to help you. So the height of CG, the tire rolling radius, velocity, weight of the vehicle, front axle weight, rear axle weight, and the wheelbase. Okay. So what happened is the vehicle is going with the constant speed of 40 kilometers per hour and the driver applied brakes. So the some weight from the rear axle will transfer to the front about CG. Okay. So about CG it will get transferred to the front. So ultimate load acting on the front axle will be, so you are, so this is the animation. So once you apply the brake, okay, so some weight from rear will be transferred to the front. So that weight needs to be minus from the rear axle weight and needs to be added to the front axle weight. Okay. And what will happen is कि ये वेट आगे के व्हील पे, आगे के एक्सेल पे ट्रांसफर हो गया, तो उसके बाद क्या होगा कि आपको पता चलेगा कि कितना फ्रिक्शनल फोर्स आपको फ्रंट में चाहिए होगा, कितना फ्रिक्शनल फोर्स आपको रियर पे चाहिए होगा, राइट? सो ऑन as per that front axle weight and rear axle weight, you will get to know ki how much energy you will be needed in the front and you will be needed in the rear to stop the vehicle. And the weight transfer formula you can see from here, that is the deceleration into vehicle's weight into center of gravity upon wheelbase. Okay, so by this formula you can find the weight transfer, that what amount of weight transfer we will be having from the rear to front. So suppose आपका vehicle suppose है 200 किलो का with driver, ठीक है? तो initially suppose 60% of weight rear में रहेगा, 40% of weight front में रहेगा. Okay, and while decelerating the vehicle, so let's say amount 15% of the weight is going to transfer from the rear of the vehicle to the front of the vehicle. So that 15% will be added in the front. So the ultimate front axle weight in that case will be 55% in the front, and that will get minus from the rear axle weight. So ultimate will be 45% at the rear. Right? Are you aligned with me? Okay, till now. Okay. So then the factor comes into the picture. Okay. So what according to you will be the standard deceleration, and how will you calculate that? So in the rule book, we have already told you that the patch will be like the rough terrain, okay, and there will be the dry soil over there, okay. So you can find the coefficient of friction of that dry soil on the internet. So let me tell you, it is around 0.4 to 0.5. It is between zero point 0.4 to 0.5. Okay. So now imagine this scenario in your head. When you need to decelerate the vehicle, so in that case, the frictional force must be maintained between your tire and your ground. Okay. So once your wheels get locked, there will be no friction at all, or your vehicle no more decelerating and in such scenario. So the maximum amount of deceleration you can take into the picture will be the coefficient of friction between your tire and roads. Okay. Beyond that, the vehicle will skid. Okay. ये बात समझ में आ रही है? This is the main thing everyone needs to understand, and everyone मीन्स ये चीज सबके दिमाग से निकल जाती है, क्योंकि रूडोल्फ लिम्बर्ट वगैरह जैसी बुक है जो आप ब्रेक डिजाइन के लिए अगर रेफर करोगे तो उसमें स्टैंडर्ड कोएफिशिएंट ऑफ फ्रिक्शन जो दिया है वो, या स्टैंडर्ड डिसेलरेशन दिया है वो 1g। तो वो 1g लेके 1g डिसेलरेशन लेके फायदा नहीं है, क्योंकि इतना डिसेलरेशन अगर आपने लिया तो your system will be over designed, or ultimately your brake rotor will fail or something else will fail in such case. Okay. So this zero point 0.7 frictional or mu is given for the concrete roads. Okay, so in colleges or in somewhere else, or initially back in 2019 and 20, so the brake test patches used to be of concrete. Okay, so in case of concrete, the 0.7g mu we used to get. So that's why I put 0.7 over here. Okay, then dynamic rear axle load, front axle load, you can find out by this formula with the help of these parameters. Okay, so the dynamic front axle load will be static plus the weight transfer, whatever will be your weight transfer, and rear axle load will be static load minus weight transfer. That I have already mentioned earlier, that the maximum deceleration will be the maximum amount of mu only. Okay. So now you will be having these kind of loads, and on that loads you will be having what amount of brake force you will need at the front and at the rear, right? So अभी पता है तुम लोगों को कितना फोर्स आगे चाहिए और कितना फोर्स पीछे चाहिए। अभी ये हो गया रिवर्स इंजीनियरिंग की, जो फाइंड करना है तुम्हें उसका वैल्यू तो पता चल गया है एज पर योर व्हीकल। ओके, नाउ वो कैसे अचीव करना है? So in this case, we will go with forward engineering approach. Okay. So in this case, the pedal comes into the picture, your master cylinder comes into the picture, and your calipers come to the picture. Okay. Because those are the variable things. Pedal ratio we can decide, right? Master cylinder bore diameters we can choose from the OEM components, or we can have a self-designed master cylinder, and the caliper diameters also we can choose. Okay. So now to play with these parameters, we'll see how to play with these parameters. Okay. So first it will be your pedal in the system, right? So which will be in your contact with the driver. So the maximum amount of force the driver can apply in the vehicle will be like average 95 percentile of men if you consider Indian males. So as per the students of the second year, third year, so the maximum amount of force can be applied is like 30 to 40 kgs. Okay, which will be eventually 300 to 400 newtons. But here we are taking the case of the endurance race. Okay, so in which driver needs to apply brake for consistent with consistency for at least 4 hours, right? Okay, so in such case, the average amount of force you can take is like 250 Newton or something, right? So with that force, you need to stop the vehicle of the 200 kgs. So do you think will that be possible? Okay. So here we need to take advantages of some mechanical things or hydraulic things. Okay. So first thing will be your mechanical advantage, which we are going to get with the help of pedal. Okay. So the pedal ratio. आपको मतलब आपने ये बचपन से एक्सपेरिमेंट देखा होगा कि कोई बड़ा पत्थर उठाना है तो हाथ से नहीं उठ रहा है तो आप क्या करते हो? एक प्लाई लाते हो, इधर पत्थर रखते हो, इधर खड़े रहते हो, वो ऊपर जाता है लाइक ए सीसा थिंग। सो ये मैकेनिकल एडवांटेज यूज होता है इन केस ऑफ पेडल्स आल्सो। सो व्हाट मैकेनिकल एडवांटेज इज कि जो आपका जिधर ब्रेक पेडल रोटेट होता है वो पॉइंट से लेके जहां पे प्रेशर अप्लाई होता है, जहां पे फोर्स अप्लाई होता है ड्राइवर से, वो डिस्टेंस बड़ा रखना है एज कंपेयर टू द डिस्टेंस बिटवीन दैट पॉइंट एंड योर tie rod, like not tie rod, the push rod linking cord. Okay, so in that case, what will be the difference between the distances now? So you will achieve that mechanical advantage through pedal. So suppose if your pedal ratio is 1:5, yeah, 5:1, let's say. So if you applied 30 kgs, then it will get multiplied 5 times. Okay, and ultimately at the master cylinder, it will receive 150 kgs. Likewise. So here we have taken that case that average lead to 50 newtons of force can be applied by average driver. So it will get multiplied by almost 5 times or 6 times. So the pedal ratio which you need to maintain is must be between 4 to 6. Okay, so that will be the ideal value to put to maintain all the pedal travel in a racing Baja buggies, and as well as don't take reference of commercial vehicles over here, because in that cases the pedal ratios are very more, and in commercial vehicle brake boosters they use. Okay, so here we don't have any means any arrangement to put the brake boosters. Okay, so in such case, we need to take only advantage of the pedal ratio, which the value is 4:6. Okay. Then your whole braking system comes into the picture. So whatever the force we used to apply in the on the pedal will get multiplied 5 times or 6 times as per your pedal ratio, and will get delivered to your master cylinder's piston. Okay, so that force and the area of the piston of your master cylinder bore, the pressure will be generated in your system, right? So what is the formula for the pressure? It's force upon area, right? So what will be your area of the master cylinder bore? So the radius into pi into radius, right? So as per that equation, pressure equal to force upon area, there will be some amount of pressure will be generated in your system, and as per the Pascal's law, that whole pressure, whatever the generated pressure, will be transferred to the caliper. Okay. Now here you need to take the advantage of the hydraulic advantage. Okay, so what will be the hydraulic advantage is the system is incompressible. Okay, so the pressure created at one point will be transferred anywhere to the other point. Okay, so now here we can increase the pressure by increasing diameter. Okay, so as the area increases, the force will be ultimately increased with the same pressure. Okay, so suppose आपने इधर suppose for example consider करो कि आपने suppose master cylinder का डाया रखा है 10, ओके, एंड उधर आपने कैलिपर का डाया रखा है 30, तो यहाँ पे अगर 10 डायमीटर पे सपोज 10 न्यूटन का फोर्स अगर आप अप्लाई कर रहे हो, तो वहां पे सेम रेशियो मेंटेन करने के लिए 30 कड़ाया मेंटेन करने के लिए 30 किलो का फोर्स जाएगा उधर, बराबर. So the ultimately force will get multiplied. Here you have taken the advantage of the master cylinder to calipers, hydraulic advantage, and ultimately that will be transferred to your calipers. Okay, then caliper will clamp the disc, and as per the diameter of the disc, the torque will be generated at the axle, your wheel axle, and you can by playing with this master cylinder diameter and caliper diameter, you can achieve whatever the required amount of force which we have discussed earlier by reverse engineering method. Okay. So now here is a typical layout of the braking system. Okay, so first we will have pedal, then we have master cylinder, then we will have fluid hoses, and it will get ultimately transferred to your calipers and breakers, whatever elements you are going to use. Okay, so what is premature locking? Does anyone know? Premature locking. अच्छा, किसी को बायस बार असेंबली पता है क्या? बायस बार असेंबली, ड्यूअल मास्टर सिलेंडर्स, बायस बार असेंबली और टैंडम मास्टर सिलेंडर. हाँ, तो टैंडम मास्टर सिलेंडर क्यों इन्वेंट हुआ वो बताओ. जस्ट आपके दिमाग में जो भी कंसेप्ट है उसके रिगार्डिंग वो बताओ. सर 50-50% के लिए डिवाइड करने के लिए ब्रेक प्रेशर 50-50% के लिए, इज इट? और 100% प्रेशर फ्रंट को भी जाता है और रियर को, दोनों साइड बराबर जाएंगे, दोनों साइड बराबर जाएगा. बट अभी मुझे बता, सर यदि उनमें से एक खराब हो जाए तो भी हाफ एफिशिएंसी में Right. This is the main reason why tandem master cylinder is invented. But let's see, अपना पॉइंट यहाँ पे दूसरा है, तो लेट्स सी कि 100% फ्रंट को भी जाएगा और रियर को भी जाएगा. बट व्हाट एवर डिस्कस अर्लियर कि वेट ट्रांसफर होता है, बराबर. तो इट विल बी नो लॉन्गर 50-50 रिक्वायर्ड फॉर द फ्रंट एंड द रियर. ओके. सो अगर रियर से वेट ट्रांसफर हो रहा है आगे, तो फिर आगे तो ज्यादा फोर्स चाहिए रहेगा, बराबर, और रियर को तो कम चाहिए रहेगा, राइट. सो व्हाई वी आर गिविंग इक्वल अमाउंट ऑफ फोर्स टू द फ्रंट एंड रियर, व्हाई वी आर ओवर डिजाइनिंग द सिस्टम. और इन अदर केस, सपोज आपकी व्हीकल, सपोज एंड्योरेंस में आपका ड्राइवर भगा रहा है एंड देयर विल बी लाइन ऑफ एट द हिल लाइन, तो उसको रुकना पड़ रहा है. बट अभी क्या हो रहा है कि व्हीकल आपका इस पोजीशन में फेसिंग टुवर्ड्स अप, राइट. सो इस केस में the weight has been shifted to the rear part. Okay, now your rear has more weight than front. इस केस में फिर rear को ज्यादा फोर्स चाहिए रहेगा फ्रंट से. so ये वेरिएबल सिचुएशंस मेंटेन करने के लिए we have introduced, means engineers have find one solution कि let's invent dual master cylinder assembly in which there will be two master cylinders for the front and the rear, and there will be the bias bar assembly over here which we can adjust with the help of just rotating the screw, and accordingly the pressure will get changed. Like suppose initially the distribution is 50-50%, so we can change it to the 60-40% or 70-30% likewise. Okay, and then there is another thing named is proportionating valve. So in which that valve will restrict the pressure going at the rear. So अभी एक सिनेरियो इमेजिन करो कि सपोज आपकी गाड़ी भाग रही है एंड फ्रंट में जो है वो ज्यादा प्रेशर लगा और रियर में जो है कम प्रेशर लगा, तो क्या होगा? स्पीड होगी गाड़ी, अंडर स्टीयर होगा, ओवर स्टीयर होगा. इमेजिन करो क्या होगा, अंडर स्टीयर होगा व्हीकल या ओवर स्टीयर होगा? ओवर स्टीयर होगा. फ्रंट में ज्यादा लग रहा है, फ्रंट में ज्यादा लग रहा है तो ट्रैक्शन छूटेगा, योर व्हीकल विल बी बाहर जाएगा, अंडर स्टीयर. समझ रहे हो? एंड अगर रियर का ज्यादा लगा वाइस वर्सा, तो क्या होगा? तो होगा ओवर स्टीयर, क्योंकि रियर का ट्रैक्शन निकल जाएगा. ठीक है, तो ये चीज ना हो तो जो थ्योरेटिकल एंड प्रैक्टिकल में जो गैप है, जो अनकैलकुलेटेड फैक्टर है which we can't calculate or which will get vary as per the situation. So for that there will be there is the introduction of bias bar assembly and proportionating valve, so which you can use in your system also. So if you are using tandem master cylinder, you must go for the proportionating valve assembly part, and if you are using dual master cylinder, then you will have advantage to use bias bar assembly. Okay. So here it's showing one graph that how the valve works and rear brake pressure and front brake pressure. So how we used to reduce the pressure at rear and ultimately transfer it to the front for the better braking efficiency. Okay. So this is just one schematic part, and now we will talk about the system split. Okay. So how many of you the teams are using inboard braking? Inboard braking, outboard braking, किसी को पता है? Yeah, the guy over here. गाड़ी पे लगाते थे, मतलब कहाँ पे लगाते थे? चासी के अंदर, एक्सेल पे. एक्सेल पे अगर लगाया आपने, मतलब एक्सेल पे रोटर लगाया और क्लैंपिंग लगाया, तो हो गया इनबोर्ड असेंबली. सो इन दैट केस व्हाट विल बी सिस्टम कॉल्ड एज front rear split, right? Because one in your tandem master cylinder, one part will go to the front and one part go to the rear. But there are few teams who are using outboard braking system, so they will have an unsaid advantage of using XR split. Okay, so it also known as diagonal split. Okay, so what is the advantage of using diagonal split? Can anyone imagine? Can anyone tell me? Right, right. So as we said, in case of failure in one line, okay, so we will have the advantage of having brakes at both front and rear. So as we see the system, so from the one section, the one line is go to the front right and it goes same to the rear left. Okay, so it has connected the wheels in the diagonal manner. Okay, so in case of failure of brakes, suppose एक system fail भी हो जाता है, तो in that case also अपने को front में और rear में दोनों जगह पे ब्रेक फोर्स मिलेगा. As we have already discussed, अगर suppose rear के brakes fail होते हैं, so our vehicle will go under steer, right? And अगर front के brakes fail होते हैं, तो our vehicle will go oversteer. So in that case, there will be unfair advantage to the other teams who are having good brakes. And in 4 hours of endurance race, there are many places or many chances of your brake system to get failed. Okay. So in such case, using outward braking and using diagonal split will be a fair advantage for your team. Okay. Now we'll talk about brake pedal and pedal travel. Okay. So can anyone tell me how to decide your pedal travel? आपकी एक रोल केज रहेगी बराबर. कॉकपिट के अंदर आपका ट्रैवल ब्रेक ब्रेक पेडल जो है उसका ट्रैवल होना चाहिए. कॉकपिट पे बाहर तो नहीं लेके जा सकते ना उसको. तो वो अमाउंट कैसे आप डिसाइड करते हो? डिसाइड ही नहीं करते हो, जितना आएगा उतना आएगा. ऐसा है क्या? नहीं है ना. So you need to decide that factor. So how will you decide that? तो अपन ने अभी देखा कि मास्टर सिलेंडर है, कैलिपर्स है. ओके. सो उसमें क्या होता है कि कैलिपर्स के जो पिस्टन्स है वो थोड़े बाहर आते हैं. जैसे अपन ब्रेक पेडल दबाते हैं ना, तो बाहर आते हैं थोड़े. And how will it retract? With the help of seals. So there are seals in the calipers which used to retract the caliper piston. Okay. So the amount of travel one piston used to do. So here we have two pistons at front left, two pistons at front right, and accordingly at rear, if you are inward brakes, then two pistons at rear. Okay, so we need to calculate all the travel of all those pistons. Okay, so the amount of travel with the help of area, we need to find how much fluid you will need to push all those pistons in front. Okay, so that much amount of fluid is going to flow in your system once you actuate the brakes. So that much amount of master cylinder travel you will need. Okay, and ultimately by multiplying with the ratios, you will have your pedal travel at the end. Okay, so these factor also you need to consider if you are going to design your self-design systems. And let me tell you, back from 2017, more than 10 teams are designing their own hydraulic braking system. And what is the advantage of using self-designed hydraulic braking system is you can have any ratios and any optimization as you want. Okay, so अगर आप मार्केट में देखने जाओ तो बेसिकली व्हाट मास्टर सिलेंडर वी यूज टू पल्सर का यूज करेंगे 12.7 mm का, और 13.2 mm का किसी बाइक का यूज करेंगे, राइट. केटीएम आरसी का यूज किया, इसका यूज किया. तो उसमें जो जो डिजाइनिंग है वो उस पर्टिकुलर बाइक के पर्सपेक्टिव होता है. उसका कर्व वेट कितना है, उसका कैलिपर ट्रैवल कितना है. उस तो इस केस में एक अनफेयर डिसएडवांटेज आपके साथ हो जाता है, वो है कि पेडल ट्रैवल का. और उस केस में आप बोलते हो कि यार मेरे ब्रेक्स तो कॉलेज में लग रहे थे, इवेंट साइड जाके पता नहीं क्या हुआ, ब्रेक्स ही नहीं लग रहे. ये सारे प्रॉब्लम्स हमने टीम्स को फेस करते हुए देखा है पिछले 4 सालों में. जब जब मैं कमिटी में था, जब when we used to monitor the brake system and when we were participant, now I was participant, then also मैं खुद सफर हुआ इस चीज से. तो हमें पता है, तो इसलिए डिजाइनिंग योर ओन सिस्टम विल बी ऑलवेज द प्लस पॉइंट, बट कंसीडरिंग कीपिंग ऑल दिस थिंग्स इन द रिस्ट्रिक्शन एंड इन योर माइंड. ओके. So yeah, so this matrix will show if the pedal ratio is higher, then brake pedal effort will be less, but in that case your pedal travel will increase. And if the pedal ratio is lesser, the pedal ratio is like I said, you can keep it in between 4 to 6, 4:1 to 6:1, right? So if you keep it as 4:1, then your pedal effort will be greater. So if you are driving, if your driver is having good physics, or he can apply 30 kilos or 35 kilos on an average, so you can go for the less pedal ratio. In such case, the brake pedal travel will be lesser, but your pedal efforts will be more. Okay, and similar case with master cylinder dia. So if the diameter is bigger, then your pedal effort will be more, but in that case, your pedal travel will be less, and vice versa in case of small die. So this is the one thing where we are mostly lagging off, most बाहर teams are lagging off कि अब इस point पे ऐसा है कि सबको खुद के अपराइट्स खुद ही डिजाइन करना है बराबर मतलब आपकी सस्पेंशन ज्योमेट्री जो है आपकी व्हील ज्योमेट्री जो है वो आपको खुद को डिजाइन करनी है तो इस केस में आपको जो कैलिपर माउंटिंग रखना है भले कैलिपर ओईएम हो बट कैलिपर माउंटिंग ऐसे रखना है कि योर लीडर should always be there on the top position of the system, wherever you are going to mount. So if you are mounting at a 12 o'clock position, 3 o'clock position, or 9 o'clock position, wherever it may be, the bleeder must be at the top point only. Q. बाजू का इमेज का रेफरेंस लेके कोई बता सकता है क्यों? What is the tendency of airflow? बॉटल उल्टी करो तो बुलबुले इधर आते हैं देखा है ना सबने किया है ना तो the tendency of air to flow in the upward direction always okay so whenever you are going to bleed your system now so there the air in the system will go to the upmost point and will stay there always so if your bleeder is at the topmost point okay so the air will automatically come out at the time of bleeding but सपोज मैं कहूँ कि ये थोड़ा ऐसा टेढ़ा होता तो यहाँ पे ब्लीडर होता अगर सपोज ऐसा टेढ़ा तो क्या होता एयर यहाँ पे जाके ऑलरेडी बैठ जाती है और फिर कितना भी आप ट्राई कर लो यू कांट रिमूव दैट एयर until and unless you change the orientation of the caliper because we don't have that much amount of pressure in the system which throw that air out with the help of one pump or couple of pumps right so ये चीज सबने ध्यान रखना है and next thing it will be your brake rotor thickness okay so I have seen many teams की जिनकी brake rotor वो self design तो करते हैं but उसका finishing proper नहीं होता है so I always recommend to surface grind your rotors at the end means the last step for the finalizing brake rotor will be the surface grinding okay so this picture itself says that अगर आपका पैड का थिकनेस अनइवन हुआ तो ये थोड़ा ओवर ड्रामेटाइज है लाइक इतना तो नहीं रहता है बट ये स्मॉल अमाउंट में भी हुआ लाइक थिकनेस वेरिएशन स्मॉल अमाउंट में भी हुआ तो ब्रेक पैड्स पे उसका फर्क पड़ता है एंड अल्टीमेटली योर ब्रेक पैड्स एंड ब्रेक रोटर नीड्स टू बी सपोर्ट एंड बहुत केसेस में ऐसा होता है कि आपका डिस्क बेंड हो जाता है ये चीज मे बी ओल्ड टीम्स में बहुत लोगों ने देखी होगी इफ नॉट आई एम टेलिंग यू ओवर हियर इस अनइवन केस में आपका ब्रेक रोटर बेंड हो जाता है एंड ब्रेक रोटर बेंड होने जाने के बाद सब सत्यानाश next is brake hoses so okay here you also need to be focused okay कि कैसे भी किधर से भी brake hoses डालिए whenever you are fixing your brake hoses now fix it with the help of the O clips okay so that and consider only that much amount of required brake hoses where in the case of steering so आप suppose left को maximum left को steer कर रहे हो तो यहाँ पे इतना बचना चाहिए कि जो आपको उतना मोमेंटम दे ओ क्लिप फिक्स करने के बाद ठीक है सिमिलर विद द केस ऑफ द लेफ्ट होज आल्सो तो ये चीज ध्यान में रखना है कंप्लायंट तो ऐसे ही 1401 स्टैंडर्ड होनी चाहिए अदरवाइज एमवीएसएस 106 उसका बर्स्ट प्रेशर 200 बार होना चाहिए तो मोस्टली मार्केट में मिलती है ऐसे केबल्स होजेस तो you don't need to grind your mind in that case it's just the thing that tying your brake hoses properly will ultimately means reduce the chances of brake failure in most of the cases okay so brake fluid ये सबको पता है synthetic glass है glycol based है .3 .4 .5 .5.1 ये बेसिक चीज है जो भी टीम में आता है उसको सबसे पहले बताया जाता है .5 we can't use because it is a कौन सा बेस रहता है वो सिलिकॉन बेस रहता है या ग्लाइकोल बेस रहता है ग्लाइकोल बेस रहता है तो अपन क्यों नहीं यूज कर सकते बिकॉज इट विल अल्टीमेटली ईट योर ब्रेक होज मटेरियल Okay, so dot .5 का application mostly in military vehicles and military purposes not that. Even though we can use dot .3, dot .4 which are readily available in market. So इन दोनों में अपने बाहर vehicle इतने high end performance नहीं है कि अपना brake temperature जो है वो 180 degree 200 degree जाए. So any one of these two fluids you can use. Okay, dot .3, dot .4, dot .5.1. Dot .5.1 is not readily available in market in many cases, so you can go for dot .3, dot .4. Okay, and this is the most important part, the bleeding procedure. Okay, so बहुत सारी न्यू टीम्स क्या करती है कि पहले मास्टर सिलेंडर में फ्लूइड डालो एंड पंप करते जाओ एंड कैलिपर से फ्लूइड निकालते जाओ. तो इस केस में आपका मास्टर सिलेंडर ऊपर है, आपका कैलिपर ऊपर है. मास्टर सिलेंडर ऊपर है ना, तो एयर का टेंडेंसी क्या होगा, रिवर्स फ्लो होने का. बराबर. तो अल्टीमेटली फ्लूइड की वजह से जितना अमाउंट ऑफ ट्राई करो थोड़ा सा एयर तो सिस्टम में रह जाता है. सो द स्टैंडर्ड प्रैक्टिस विल बी कि गेट वन ब्लीडिंग पंप. ओके, तो ऐसे रहता है मोस्ट ऑफ द केसेस में. तो वो वी कैन डायरेक्टली अटैच टू द bleeder board of the caliper, and इस केस में रिवर्स ब्लीडिंग करके let the air bubble comes out from the master cylinder reservoir. Okay, so in that case your fluid at the start of the filling fluid inside your system now, the fluid will go from the master calipers to the master cylinder, and in such case there are very less chances that the air will remain in your system. Okay. So yeah, this is the standard process. So once you take out air from the reverse bleeding process, then you can do once again the standard bleeding. Okay, so whatever air that will remain in your calipers now will get eventually out of the your system. Okay, thank you so much. Yeah. So we are